Hello class, in this video we're going to finish up the test 3 review packet. My name is Michael Elmes and we're going to start with question number 101. So it says simplify each expression. Okay, so we take like terms and kind of multiply them together. So negative 2 times negative 5 is positive 10. X to the 4th times x cubed is x to the 7th, right? We have the same base, you add the exponents for multiplication. All right, so that's 101. Number 102, let's handle like terms. So negative 8 divided by 2 is negative 4. Now I have an a to the minus 3 on the top. If I bring it to the bottom and make the 3 positive, that's okay, right? To get rid of the negative exponent, you flip the base, or you take the reciprocal of the base and make the exponent positive. So I have an a to the negative 2 on the denominator. I simply bring it to the top and make the a squared positive, or the exponent positive. B to the 6 over b to the 8, that would leave you with 2 b's on the bottom, right? Right, if I have 6 b's on the top and 8 on the bottom, when I cross out, I'm left with 2 on the bottom. So the last thing to do is just clean up the a. So we'd have negative 4 a b squared, and that would be my final answer, right? A squared over a cubed would leave me with 1 over a. Finally, number 103, I'm going to distribute this 2, right? So this becomes 7 squared times x to the minus 6 times y to the 10. To get rid of the negative exponent, you relieve this as well. 7 squared is 49. To get rid of the negative exponent, we flip it, make the exponent positive, and y to the 10 stays where it is. And that's my final answer for number 103, 49 times y to the 10th over x to the 6th. Let's take a look at problems 104 to 107. It says determine the value of each exponent, or each expression. So I can rewrite this as the cube root of negative 64, and I'm going to put the squared on top. So what number multiplied by itself 3 times is negative 64? Isn't negative 4 times negative 4 times negative 4 negative 64? So you're left with negative 4 squared, which becomes positive 16 is your answer. For 105, to get rid of the negative exponent, we flip the base or take the reciprocal. So we make this 4 over 3 squared, which becomes 16 over 9. 105 is done. 106, I don't know what this answer is, so I'll say it equals x, and I know I can rewrite this as 5 to the x equals 1 over 25. Now remember, if I know 5 squared is 25, 5 to the negative 2 is 1 over 25. So the value of x that will get me 1 over 25 would be negative 2. Right? That's what we'd have to put in here. So your answer is negative 2. Right? 107, if they don't write anything underneath the ln, it's assumed there's an e. So again, I'll write e to the x equals e to the 4. And the value of x that would make that true would be x equals 4, right? I'd have to put a 4 in here to get both sides of the equal sign to match. So your answer for 107 is 4. Let's keep going. Next page. Okay, so let's handle problems 108 through 110. Use an algebraic model to solve the equation. All right, so I have 5 to the x equals 1 over 25. We could rewrite this, right, using logs, right? Here's my log. The base of my exponent's 5. 1 over 25 comes inside, and that equals x. And now if you want, you have a couple of options. You could say, all right, 5 to the x equals 1 over 25. What value of x makes that true? The answer would be negative 2, right? That's one way to do it. It says algebraic, so that's a way. You could also graph it, right? I could graph y1 is 5 to the x, y2 is 1 over 25. The intersection would be my answer, okay? Let's use algebra to do number 109. All right, so I have 10 to the x equals 80. I could take the log of both sides. Log of 10 to the x equals log 80. Then I can rewrite using properties of logs. I bring the x in front of log 10 equals log 80. Now you should know that log base 10 of 10 equals 1. So this is really like saying x times 1, okay? And just to prove that to you, this is something you kind of want to have memorized, right? Log base 10 of 10 equals 1, right? So I'm going to just rewrite this as x equals log 80, right? Because x times 1 is the same as saying x. So now, to finish the problem, you will need your calculator. Log 80 equals, and it says round to 4 decimal places, so here's my number. Whoops. We're going to round this to 4 decimal places. So here's my final answer for number 109, 1.9031. And then finally, whenever I have an e in the problem, like on number 110, I like to take the natural log of both sides, right? And then I can rewrite using properties of logs, which would be x ln e equals ln 8.5. And let's move this over here, right? Now you should know that ln e is equal to 1, right? Just like log 10 is equal to 1, right? Those are two special properties you kind of want to have memorized, right? Again, log base 10 of 10 is 1, and natural log base e of e is also 1. Okay, so you can essentially just cross that out, right? So we have x times 1 equals natural log of 8.5, right? Again, this ln e is equal to 1. So it's really like saying x times 1, which is just x. All right, so I do need to do ln of 8.5, or the natural log of 8.5. I get 2.1401 as my final answer. So I write x equals 2.1401. All right, that's it for the test 3 review packet. Thanks for watching. Good luck on your exams. Have a great day.